Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on sampling distribution part 5. Let us recall the previous session. In the last session, we have discussed about the sampling distribution of means. In that, two different cases, the standard deviation of population is known and unknown. That means, if sigma is known and sigma unknown. In these two cases, we discussed about the sampling distribution of means. Similarly, standard deviation of population and finite and infinite populations and problems on sampling distribution of means. So, let us recall the previous session. In the last session, we have discussed about sampling distribution of means in which two cases, the sigma is known and sigma unknown, and also in two different cases, finite and infinite populations. So, if the sampling is done with replacement, that comes under infinite population, and if the sampling is done without replacement, then that comes under finite population. And also we have solved some problems on sampling distribution of means. Coming to today's presentation, today I would like to discuss about sampling distribution of proportions and then sums and differences, and we solve two problems on the same. Sampling distribution of proportions. Now again there are two different cases, infinite population and finite population. Let us consider the first case, infinite population. That means the sampling is done with replacement. So, in sampling distribution of proportions, first we know what is sampling distribution, the set of samples and corresponding proportion. For example, if there are k samples S1 to Sk and we have calculated k proportion for each sample, then the set of these values are denoting these in the form of a table. So, we can represent the sampling distribution in the form of a table also. So, simply what is the sampling distribution? The set of the samples and corresponding statistic. Now, if we find the proportions for each and every sample, that is called sampling distribution of proportions. Now, let P be small p be the probability of occurrence of an event which can be considered as success, and Q, where Q is 1 minus P, since P plus Q, the total probability must be 1. So, Q is probability of non-occurrence which is considered as failure. We know that the total probability is always equal to unity. So, the probability of success plus probability of failure or probability of occurrence plus non-occurrence must be equal to 1. So, here P is the probability of success. And now draw all possible samples of size n from an infinite population. Here we have considered the infinite case. So, let us draw the possible samples of size n from the given population. Then compute the proportion capital P for each and every sample and arrange all the values in the form of a table, or else the set of these two, the sample and corresponding proportion, is called sampling distribution. So, sampling distribution of proportions, that is given here. Now, for this sampling distribution of proportions, if we calculate the mean, so which is denoted by mu suffix capital P, which is called the mean of sampling distribution of proportions. Similarly, if we calculate standard deviation of this sampling distribution of proportions, so sigma suffix p, which is the standard deviation of sampling distribution of proportions. So, the mean and standard deviation of sampling distribution of proportions are denoted by mu suffix p and sigma suffix p, and are given by mu suffix p is equal to the population proportion, mu suffix p is small p, and sigma square suffix p, that means the variance, is pq by n. So, if you want sigma suffix p, just consider the square root. So, p into 1 minus p by n, that is the standard deviation in sampling distribution of proportions. and this is in the case of infinite population. Similarly, let us consider a finite population and draw all possible samples of size n from this finite population, and again find the statistic S as the proportion. So, again the number of samples S1, S2 and so on, k samples. Let us find the proportion P1, P2 and so on, Pk. So, that means consider the sampling distribution of proportions. Then in this case, finite case, the mean of sampling distribution of proportions is again equal to the population proportion, and the standard deviation is PQ by under root sigma p is under root PQ by n into the finite population correction factor. So, since it is a finite population, here this factor comes in the picture, whereas in the previous case infinite population it is simply PQ by n. So, the standard deviation is under root PQ by n. So, these are the two different cases in sampling distribution of proportions for finite and infinite samples. Now, coming to the sampling distribution of sums and differences. Now, sampling distribution of sums and differences. Now, here what we consider is, let us suppose there are two populations, population 1 and population 2, and the mean of the population 1 is mu1 and mean of the population 2 is mu2. Similarly, sigma 1 standard deviation of population 1, sigma 2 standard deviation of population 2. So, here we consider two populations because we are dealing with sums and differences. Sum means there must be at least two populations. Similarly, difference also. So, mu1 and mu2 are the means of population 1 and population 2 respectively, and sigma 1 and sigma 2 are standard deviations of population 1 and 2 respectively. Now, let us calculate the difference between these two. For example, mu1 minus mu2, the difference between the means, or sigma 1 minus sigma 2, the difference between the standard deviations. So, in general, let us compute statistic S1 for samples of size n1 drawn from first population, S2 for samples of size n2 for second population. Then we find the difference between the two statistics S1 minus S2. This statistic can be mean, or so if it is mean mu1 minus mu2, if it is a standard deviation C1 sigma 1 minus sigma 2, like that we can consider. So, here we have two statistics S1 and S2. So, S1 minus S2 is the difference between the two statistics, and S1 plus S2 is the sum of the two statistics. Now, let us consider the difference. Then we can form the sampling distribution of differences. If you add the two values, then we can form that sampling distribution of sums. Now, let us discuss about these two one by one. So, the mean and standard deviation of sampling distribution of differences of S1 and S2. So, S1 minus S2, the mean and standard deviation of sampling distribution of differences of S1 and S2 are denoted by mu S1 bar minus S2 bar and sigma S1 bar minus S2 bar. So, here these two things can be calculated. The mean, in the case of difference, the mean of differences is equal to difference of individual means, and the standard deviation is the square root of sum of the individual squares of sum of the individual standard deviations. Similarly, for differences, here in the difference we have calculated these two values. Similarly, for sum also, the mean of sum of the two statistics is equal to sum of the individual means of the two statistics, and the standard deviation is the same in both cases. Now, let us solve some problems on the same. So, here two populations are given U1 and U2. Now, we need to calculate the mean of first, mean of second. So, here we can consider these as samples U1 and U2. So, mu U1, mu U2, and the difference between these two, and sum standard deviation of individual items. So, for example, let us consider the first one U1 is 279. Simply the mean mu U1 is the average. So 2 plus 7 plus 9 divided by 3, which results as 6. Similarly, U2 is 3 comma 8. So mu U2 is 3 plus 8 by 2, the average of the two values. So 5.5. Now, for the third one, we need to calculate the difference between the two, U1 minus U2. So 2 minus 3. So how can we find this U1 minus U2? Just by subtracting the elements of second set from the first set. 2 minus 3 gives minus 1, 2 minus 8 minus 6, 7 minus 3, 7 minus 8, 9 minus 3 and 9 minus 8. Now, let us calculate mu U1 minus U2 for this. So, here by adding all these values divided by total 6 values. So, here this minus 1 and plus 1, minus 6 and plus 6. So, 3 by 6, the answer is 0.5. Here we can cross check the property that mu U1 minus mu2 is mu U1 minus mu U2. So, here mu U1 is 6 minus 5.5, obviously you will get 0.5. Similarly, we need to calculate sigma U1. Sigma is the standard deviation. So, to find the standard deviation, let us calculate the variance first. So, the sum of the squares of the deviations. So, that means, for example, U1 for AI minus the corresponding mu U1 whole square by total number of elements. So, that is 2 minus 6 whole square plus 7 minus 6 whole square plus 9 minus 6 whole square by 3. So, like this we can calculate the variance first, then the standard deviation also. So, here after simplifying and calculating the value 26 divided by 3 and hence the variance is given by 8.66 and the standard deviation can be obtained by taking the square root of this. So, sigma U1 is under root 8.66. Similarly, we can calculate for second set U2 also. So, U2 equal to 3 comma 8, set 3 comma 8, then sigma U2 is from 3 corresponding mean 0.5, the mean of U2 is 5.5. So, from 3 let us subtract that 5.5 whole square, 8 minus 5.5 whole square by 2 and this results as 6.25. Now, we need to find the standard deviation for these differences and sums also. So, U1 minus U2, the values are minus 1, minus 6, 4, minus 1, 6, comma 1. For this, we need to calculate the standard deviation. And what is the mean of this mu U1 minus mu2? Mu U1 minus U2. So, the mean of differences is 0.5. So, first the square root of U1, the square of sigma, that is the variance. So, minus 1 minus 0.5 whole square plus so on plus the last value. So, from each individual value subtract this corresponding mean divided by total number of values. So, the variance characterizes the variability of the elements. So, the variability with the each and every element with that corresponding mean. So, which is called the deviation, mean deviation. The deviation of the actual values from the mean. So, sum of the squares of deviations divided by total number of elements. And the result is, so by calculating the numerator value, we get 89.5 divided by 6, which results as 14.9166. And hence, the standard deviation of differences is given by the square root of 14.9166, which results as 3.8622. Similarly, if we consider the sum of the two sets, so the values are 2 plus 3, 5, 2 plus 8, 11, then 7 plus 3, 10, 7 plus 8, 15, 9 plus 3, 12, 9 plus 8, 17. Now, we can calculate the mean for the sum of these values. And what is that? Sum of all these values divided by total number of values, 16. So mu u1 plus u2, that means the mean of sum is equal to 69 by 6, which results as 11.5. And also the standard deviation u1 plus u2, from each individual value subtract this mean whole square plus so on. So sum of the squares of deviations of the values from the actual or corresponding mean, and which results as 14.9166, and the standard deviation is the positive square root of 14.9166, 3.8622. So like this, we can use the sampling distribution of sums and differences for the given, and using the sampling distribution of sums and differences, we can cross check these conditions also. So like in both cases, the standard deviation of difference or standard deviation of sum, in both cases the standard deviation of differences u1 minus u2 and sum, the result is under root sum of the variances of each individual sets u2, sigma square u1 plus sigma square u2. So in both cases the result is the same, that we can cross check from all these values. Now coming to the second problem, the mean voltage of a battery is 15 volts and standard deviation is 0.2 volts. Find the probability that 4 such batteries connected in series will have a combined mean voltage of 60.8 or more volts. So again I repeat, the mean voltage of a battery is 15 and standard deviation is 0.2. Find the probability that 4 such batteries connected in a series will have a combined mean voltage of 60.8 or more volts. Now coming to the solution, so it is let us consider 4 batteries of different brands, for example A, B, C, D, and let us denote the mean voltage of these batteries x bar suffix A, x bar suffix B, x bar suffix D, C and x bar suffix D, and the mean voltage of a battery is 15 and standard deviation is 0.4, and 4 such batteries are connected in a series. So the mean of sum of 4 batteries, so that means x bar A plus x bar B plus x bar C plus x bar C, x bar D. This comes under sampling distribution of sums. So the mean of sum of 4 means, this is equal to 15 plus 15, each one is having 15. So which is 60 volts. Similarly, the standard deviation of x bar A plus x bar B plus x bar C plus x bar D, which is under root individual values x bar A, x bar B, so which is under root sigma square A plus sigma square B, 4 batteries. So sum of 4 variances and each variance is given 0.2. So 4 into 0.2, which results as 0.4. Now the question is, find the probability that 4 such batteries are connected will have combined mean voltage. So now we have calculated these 2 values. The first one is mu of sum of 4 batteries is 60 volts and standard deviation is 0.4 volts. And it is required to calculate the mean voltage is 60.8 or more volts. So x equal to 60.8, x equal to 60.8. Then the value of z is x minus mu by sigma sum. So 60.8 minus 60 by 0.4. So which results as 2. Now it is required to find the probability of the mean combined voltage is 60.8 or more. So greater than or equal to 60.8, which is equivalent to z greater than or equal to 2. So, that means 2 to integral 2 to infinity f of z dz. So, if you draw the rough graph, you can identify what is the required region to calculate. So, this is z, f of z 0 and z equal to 2 here. We need to calculate this shaded region. We want 2 to infinity, this shaded region. But using the standard normal distribution table, we can find from 0 to some z, 0 to 2 we can calculate. And we know that this region is equal to half. Since the curve is symmetric, the negative portion is equal to corresponding positive portion and total area is 1. So, this half side region is equal to 1 by 2, 0.5. So, from 0.5, let us subtract the area from 0 to 2. So, which gives the required region. So, 0.5 minus integral 0 to 2 f of z dz. So, from the standard normal distribution table, we can find this area from 0 to 2 as 0.4772. So, the area from 0 to 2 f of z dz is 0.4772 and after calculating the probability that when 4 such batteries are connected, then the combined mean voltage is greater than or equal to 60.8 is 0.0228. In today's session, we have discussed the sampling distribution of proportions. Again, in that 2 different cases, finite and infinite populations, and then sampling distribution of sums and differences. And also, we have solved some problems on the sampling distribution of sums and differences. In the next session, I would like to discuss about T distribution, chi-square distribution and F distribution. So, this is for today's session and we will meet in the next session. Thank you.